I'm going to teach you how to create a polygon in Desmos and how to use the distance formula. First thing that you want to make sure that you're using the Desmos Virginia Standards of Learning version of the calculator. The other version is going to have some different kinds of functions, and you want to make sure that you're practicing with the one that you're allowed to use on tests, quizzes, and the SOL. Okay, so let's start there. So first of all, why would we even want to make a polygon? Well, there's lots of reasons you might want to make a polygon, but most specifically, when we're trying to determine the most specific classification of a given parallelogram, we can graph the polygon so that we can have a visual proof of what it is. And we can input it so that we can calculate all the distances quickly. Because in order to prove what specific classification of parallelogram it is, we need to test to see if the opposite sides are congruent or whether all four sides are congruent. And then we need to test the diagonals. Okay, and the determination of those measurements will tell us what specific parallelogram we have. All right, so let's take a look at our first problem. Determine the quadrilateral's most specific classification. Cool. So first thing we want to do is define our points. We have A, B, C, and D. A is 9, -4. So I'm going to go in, and in the first part, this is an expression. I'm going to type A is equal. I'm defining it in advance. That means anywhere else further down the line, when I say use the letter A, I am discussing this particular point. Okay, so 9, -4. The calculator, you're telling the calculator, hey, if you see an A, 9, -4. Now you'll notice that when that happens, it brings up this little point that is graphed right here for you. That's awesome. If you want to add a label to it, you can. Just be aware that the label does not impact the expressions. Okay, so you need to label it in front also. All right, so we have A, and now we need the others. B is 8, -2, so B equals 8, -2. And I'll label it because it's always nice to have a well-labeled graph. 2, -5. 2, -5. The label. And 3, -7. And we're done. Now, just looking at it the way that it is now, you might be able to guess what type of shape this is. Okay, but you wouldn't know necessarily for sure. It's a little vague. So now that we have the points of our polygon, we're going to actually connect the points using the polygon function. Now you should just be able to type in polygon here in lowercase in a parenthesis, and it should work as an expression. However, sometimes I have noticed that Desmos gets a little funky about that. So instead, you're going to go down here to your keyboard input in the lower left-hand corner where it says Show Keypad, and then all the way to the right, above the blue return bar, 3 buttons up, there's a Functions button. This is where all the pre-programmed equations and expressions live. Super helpful. Trig, you have Statistics, so on our tabs on this menu, Data Distribution, and then Miscellaneous, which is right now where we're going to live. Right, so Miscellaneous at the bottom, you have Distance, you have Midpoint, which we're going to use later, and then you also have Polygon. Yay, Polygon. So click on Polygon and you'll notice that it automatically has entered it into a new expression. All right, sweet. So now you could input it by re-entering all the points, but since we were good enough to label our points in advance, all we have to do is type in A, B, C, D. Ta-da! Pretty cool, huh? Now, sometimes something will happen, like let's say it gets twisted, or it connects the dots in the order that you list them. So if you would like it to go from a specific point to another specific point, just reorder it if it's not giving you the shape that you were intending to get. So now looking at this, we can tell that this polygon, clearly a rectangle. But we do need to be able to prove it mathematically. A good note also is that you have lots of options as far as the lines, the fill, the color of these polygons. So if you're feeling creative, the same goes for all of the points, although to change the points you have to go into settings, and then you'll notice that there's lots of different options for that, including the ability to drag and drop them. Okay. All right, so now we have a visual proof. Let's talk about a mathematical proof. First thing that we said we needed to do was to find the lengths of each of the sides. All right, so in order to tell whether it's a rectangle, parallelogram, square, or rhombus. So we're going to use the distance formula to find the distance between 2 points. Okay. Again, you should just be able to type in distance, lowercase, and then a parenthesis. Looks like it took it this time. All right. And then I'm just going to pick the two distances. I'm going to pick my top and bottom first. So C comma D. You'll notice the distance magically appears on the bottom. Now, if you're having trouble getting the function to show up just by typing it, please also be aware, and you'll notice I can just click below to get a new expression. In the show keypad, where we were before, same menu above the blue button, functions. Also under miscellaneous, you'll have a distance formula. So if you click on distance, it will also automatically enter that for you. So we have CD, which is our short left side. So now let's do the short right side. BA, B comma A. And again, we're using our predefined letters. All right, so those two are congruent. That's a good start. You can also just copy and paste. So I'm just going to copy and paste this down here, and then I'm going to change it to CB, my top line segment of my polygon, and then I'm going to copy and paste it again. Hit Control V. DA. All right, so if it were a square or a rhombus, all four sides would be congruent. In this case, we do not have four congruent sides. However, opposite sides are congruent, which means it's a parallelogram of some type. A parallelogram or a rectangle. Now, looking at the picture, we can probably imagine that it's a rectangle. However, to prove it mathematically, we also need to compare the diagonals. So we're going to need two more distances, the distance of the diagonal CA. And again, I just copy and pasted that. Remember, it's highlight, control, copy, new expression, highlight, control V. So CA and then DB. All right, so you'll notice that we have congruent diagonals. So between a parallelogram and a rectangle, yes, it is a rectangle as we had imagined because it has parallel diagonals, or excuse me, congruent diagonals. If the diagonals were non-congruent, it would be a parallelogram. So that is how you enter points in. Remember, first thing you need to do if you want to do a polygon, enter your points. Okay, make sure that they're labeled. Use the keyboard to find the function under miscellaneous for polygon, and then input the points that you had predefined. Then you'll want to measure the distance of each side, and to do that you go into the same menu, functions, miscellaneous, and hit distance. Again, typing it in generally works, but it can be a little fussy, so keep that in mind. All right. And if you have any questions, let me know.